Hello. So the last couple of videos, I've been doing a lot of, we've been doing a lot of projectile motion. We'll keep doing some projectile motion, but I think it may have seemed more confusing than it really is because I kept everything in terms of variables, and we worked with the formulas and the variables. But what I want to do is take all those things that hopefully I've taught you or that you've had exposure to over the last couple of videos, and just do a bunch of problems because I think this is all about experience and getting the intuition and just chugging through a lot of problems. So let's do a straightforward one, kind of going back to the ball throwing game. So let's say I throw a ball. So I throw a ball straight up, throw a ball up, that the total time the ball is in the air is, I don't know, let's say it's 7 seconds. 7 seconds. So how fast did I throw it up? How fast did I throw straight up? Not throw up, or how fast did I throw the ball up? And then how high did it go? How high did it go? So I could, we figured out a bunch of formulas, and we could plug it straight into those formulas and solve this problem in 10 seconds, or probably more like 2 seconds. But what I want to do is just actually go through the same logic we went through to get the formulas, but I'll work with the numbers, and I'll show you this isn't something where you even have to memorize formulas. So it took 7 seconds, right? The ball took 7 seconds to go all the way, to go up, and then to go down, right? And assuming no air resistance, it took the same amount of time to go to its peak as it took to go down, right? So it took 3.5 seconds to go up. Right? It took time is 3.5 seconds, and then that's 3.5, and then it took another 3.5 seconds to go down. Right? 3.5. So it took 3.5 seconds to get to its peak. So what does that tell me? Well, it tells me that in 3.5 seconds, the ball went from whatever the initial velocity it was when it left my hand. The ball went from, v sub I is equal to, whatever. It went from that initial velocity. This is the ball. This isn't a number. And then by the time it got to the top, to the kind of the peak of its travel, it got to 0 velocity. So I'll call that v sub f, or the final velocity, right? It went from whatever speed I threw it at to 0 in 3.5 seconds, right? So now we could just use, we don't even have to use a formula. We can kind of think of it intuitively. How fast am I decelerating? How fast am I decelerating? So what I'm decelerating at the rate of gravity, right? We know that because that's what's slowing down the ball. So we know that acceleration is equal to minus 10 meters per second squared. And so what do? Well, acceleration is the same thing as the change in velocity. Is the same. Acceleration times time is the same thing as the change in velocity, or the change in velocity divided by time is acceleration. So let's say that. So change in velocity. Well, the change in velocity is equal to the final velocity minus the initial velocity, and that equals acceleration times time. So minus 10 meters per second squared. Meters per second squared. I'll stick with the units this time. Times time. So it did that in 3.5 seconds. Times 3.5 seconds. So this seconds cancels out with one of the seconds in the denominator here. And so let's see. So I get minus vi is equal to minus 350 meters per second, right? Minus 10 times, no, that's 3.5, not 35. So it's minus 35 meters per second. Something was looking suspicious. Minus 35 meters per second, and then of course, multiply both sides by -1. And the initial velocity is equal to 35 meters per second. That wasn't too bad. You don't even have to really, do it formally like this. You could just say, well, I'm throwing it at some speed, right? It took, of the total time, it takes half of that time for it to go to 0, right? So I threw it at some speed, and it took 3.5 seconds to go to 0. And it's decelerating at this speed, right? So every second, it's getting 10 meters per second slower. Every second I go, it's getting 10 meters per second slower. So if it took 3.5 seconds then I must have, to go to 0, I must have started off at 35 meters per second. If that confuses you, use the formula. But I want to give you a sense that you can kind of just use your intuition, right? Every second it travels in the air, it's getting 10 meters per second slower. It took 3.5 seconds to go from whatever speed you threw it at to 0. So it must have started off at 35 meters per second, right? At t equals 1, it was going 25 meters per second. At t equals 2, it was going 15 meters per second. At t equals 3, the ball is going straight up at 5 meters per second. And at t equals 3.5, the ball is stationary. It's right at the top, and then it starts decelerating downwards. Let's do some more problems. I don't like these colors. Let me switch to something nicer. Okay, let's do another classic, and also in that problem, I didn't figure out how high the ball went. So once again, the total travel time is 7 seconds, right? We know the acceleration is minus 10 meters per second squared. And we know that the initial velocity now, we figured it out, is 35 meters per second. So to figure out how high it went, so let's just draw that part. So the ball is going up, right? And we figured out just in its upward portion to go from vi is equal to 35 meters per second to, let's call this vf, is equal to 0 meters per second. It took the ball 3.5 seconds. 3.5 seconds, right? Because this is half of its travel time, and then it took another 3.5 seconds to come straight down. Well, we could just use our fairly straightforward formula that, change in distance is equal to the average velocity times time, right? And this is, this should be pretty intuitive to you. It shouldn't even be viewed as a formula. Hopefully, it's starting to be viewed as maybe even common sense. But anyway, so what was the average velocity? Well, the average velocity is just the average of your initial velocity and your velocity at the top of the curve. So that's 0. So the average of 35 and 0 is just 35 divided by 2. So it equals 35 over 2. And then what's the time? 3.5 seconds. 3.5 seconds. And I could use my trusty calculator provided by Windows. 35 divided by 2 times 3.5 is equal to 61.25 meters. 61.25 meters. Pretty easy. And so hopefully you're realizing that we used a lot of formulas and things, and the formulas we're getting they're all over the page last time. But when you actually do it with numbers, it's not so bad. In the next video now, I'm gonna just keep doing a bunch more physics problems because I think you're probably tired of this ball throwing business. See you soon.